right, so for those of you who may not be familiar with me, don't know who I am, my name is Rashida Lewis. I am a newly minted assistant professor here at UGA, so I started in August. I am with Edie, and I'm also in electrical and computer engineering. And today we will talk about the efficacious engineering student and what exactly are we preparing our students for. So I talk about efficacious, I'm really talking about students and their self-efficacy development. And self-efficacy at its core is really the belief of one has to be able to do something, right? Like they believe that they can do something. And self-efficacy is developed in 4 major ways as outlined by Bandura. So the first one are mastery experiences, which essentially is practice makes perfect. The second one is vicarious experiences. It's exposure. You can't be what you can't see. The third is social persuasions. You're great at X, so maybe you should consider doing Y. And then the fourth is somatic and emotional states. Like when I do this activity, it makes me feel warm and fuzzy. I like doing it. So in thinking about self-efficacy development, how do we promote this development in our classrooms? And I do notice that we have a mixture of both faculty and students in the room. So I would like for you to pair up with people nearby you, so your neighbors. And I want you to think of things that you either incorporate in your class if you're a faculty member, or as a student, things that you have seen done in your classes by your instructors, or if you're a GTA, the things that you help out with, that really fosters self-efficacy development. And I want you to think of 3 things, so come up with 3 things amongst your group members, and be prepared to report that out. And I left the box at the bottom so that you can kind of remember to see which boxes do these things actually fall into. So let's take a few minutes, find a neighbor, say hi, introduce yourselves, and we'll come back together in about like 5 minutes. So now's the time to share what you discussed with the entire room. So could I have someone from each group or pair present 1 or 2 things that you guys really developed or came up with that you like from self-efficacy development? Things that have happened in your class, whether you experienced it as a student or incorporated it as an instructor. So who would like to go first? This group right here.
Yeah, so after discussion with my partners, we just, I mean, in my opinion, I think the third point might be the most important to me, because sometimes.
And what's the third one? Just
the social
persuasions. Okay, just want to make sure everyone knows.
Yeah, so it's kind of like the third one, but I would say the sense of the progressive is very important to me. So when I was like getting some class which is very abstract or very hard, if the teacher is just continue teaching without giving you any sense of the realistic content, you may find, oh, what the heck is the content, or what is teacher talking about? Mm-hmm. So I'm always hoping like if the teachers can attach some realistic content to those kind of abstract ones, which will make me feel a little bit easier to get start of the class, and then it's like the third one. So I'm able to do the first step, so I'm able to do the next one. So it's kind of like the third one. So, and some of my partners also value the fourth one, like the emotional parts. Like maybe the teacher is very emotional, like he or she like show their passion to this kind of subject, and also they can relate those kind of emotional ones to the industry or the following like career stuff. So this would be very helpful to the students. And also maybe they didn't show very detailed information, but at least their like positive emotion will influence or affect the students to become better. So that is our point of view.
Okay, thank you for sharing. Anyone else? Yeah.
We sort of didn't get into any of the corners, but we had an interesting discussion about self-efficacy in John's context of teaching writing, because it's very common and somewhat acceptable in engineering to say, I'm not a good writer. So you start a task or teaching with people who affirm their lack of self-efficacy, so it becomes visible in that setting. So we're sort of exploring that as a challenge, a particular challenge to his instructional context.
One of the things that happens is, while that stereotype certainly has a kernel of truth to it, once you get some of them together, in fact, there are usually one or two who are not only fairly good writers, but they have a fair amount of confidence in them. So if they're doing sort of active learning, think, pair, share type stuff in class, the ones who maybe are less confident sort of gravitate toward them. And one of the things I have them do is once if they write a short response to a prompt that I've given them, once they're done, then they have to explain it, talk about the choices they made and how they envision the audience and these sorts of things. And there's almost like an all hands on deck, strength in numbers sort of thing. It seems to lift everybody up a little bit anyway, which obviously is really important.
Okay. Anyone else? Can I get one more volunteer? Yes.
We essentially spoke about essentially what we think promotes self-efficacy, just basically kind of different things that we do. We mentioned, I think we looked at mastery experience, which is just repetitiveness. I know one of my professors basically has the students do a lot of problems and class problems, so everybody can essentially voice out and practice, which would probably give a bit more confidence to that individual. Then we also brought up the social persuasions, basically, and this one is essentially when you have group projects. So you're basically going and you're going to be in a group, and as a student, the things I've experienced when I'm in a group is two times in a group. Either everybody inside the group is basically contributing adequately to the project, and in the other case, maybe one or two of you are carrying the entire team. And at least in my own experience, in the time when everybody's contributing, there's a lot more knowledge that you basically acquire, and then that's again promoting that confidence that you know what you're doing. And then in the other case, where you're carrying most of the group, at least personal experience, there's this tendency that you're going to give information out. So you want to make sure that it is concrete and you're not giving it the wrong information. So it essentially helps you kind of establish what you already know and make it more grounded. But that's pretty much it.
All right. Thank you for those of you who shared. Can we give a round of applause for our brave souls? All right. So we all talked about sort of briefly what self-efficacy is, how it can be developed in different ways, sort of how it is fostered or not fostered in certain ways. But self-efficacy is really nuanced. And what I mean by that is it's really task related. When you think about self-efficacy development, students typically attach it to a task. I am able to do this successfully, and so I am this. Or I am unable to write, I am not a good writer, so now their self-efficacy in writing is little to non-existent. And so how students develop self-efficacy in a domain is greatly dependent on how successful they are in related tasks of that domain. And in this case, the domain is engineering, or is it? So I want you guys to think about what kind of engineer are you? How would you answer this question? I want you to turn to your neighbors again and answer this. What kind of engineer are you? So I just want to take a pause real quick. We are going to get back in discussion really quickly, but I want you to notice that I added another question up here. So in addition to what kind of engineer are you and how you describe it, I want you now to think about how do you think your students answer this question. So does someone want to volunteer a response to the first question? How would you answer this? How do you describe the type of engineer that you are? Yes, excellent.
Eric and I are on the same page. We are more analytical. We're mathematical. The math, seeing the math in a system is going to tell us how that system is going to behave. So we are math people.
Okay.
Can I
Anyone
ask you a
else?
question, like a follow-up question?
Yeah.
And how far does this answer differs from like, so if I asked you or if somebody else like downtown asked you, and how far would your answer differ?
Oh, well, it depends. I guess I would go more into detail depending on their interests.
What would be your first shot? What would you think?
Oh, of course, mechanical engineering.
Okay. Because
And now I'm ECAM because my students are from all over, so I have to learn all of them.
So I'm asking this because we had a longer discussion about like that the easiest way to say describe your type of engineer is like the field. So I'm a mechanical, I'm electrical, and depending on how much knowledge you assume the other person has, the more detailed you would be in your answer.
Okay. Great. Fred?
Yeah, I was gonna say the same thing. You know, Madison and I are in very different disciplines. So our first response to that was, she's an environmental engineer, I'm an electrical and computer engineer. But we both went, but that's not why Rashida is asking us this question. And so we started thinking about things like, do you view things from a big picture perspective, or are you a detailed person? You know, and that kind of led us into what brought us into engineering, rather than what kind of engineer, but what motivates us as engineers.
All right. Anyone else? Okay, thank you for those responses. Now, who wants to talk about how do they think their students respond? And I think we got a little bit of that, but get some targeted answers.
I have a very strong opinion about this, so I don't know if somebody else might have to. I just feel like the students are forming who they are as engineers still, so I think they would answer like they're becoming engineers. And I think the responses that my colleagues gave are good examples. They would say I'm like a mechanical engineering major, like, or I'm studying, you know, biological engineering. So they know, it's like the way they would answer, I think, shows that they're in the process of becoming like those engineers and identifying like kind of what Dr. Bayet said, which is what motivates them. I think they're still learning about like what's going to motivate them, thinking about what careers they're going to do when they finish school. So that's my
Anyone else? All right, so all of those were excellent responses, and funny, or I find interesting that, you know, Fred said that's not why she asked us this question. Well, actually, in fact, it is. And so thinking about these differentiating questions of, you know, are you going to say I'm a ex-engineer, or am I an analytical person? Am I into the details? Am I oriented? Am I research focused? Am I teaching focused? Does the answer to this question matter when we think about students? Does it matter what type of engineer they're becoming, whether it's an engineer broadly or a mechanical engineer? And why or why not does the answer to these questions matter? Any thoughts? Right.
Yeah, so I think it does matter. And I think oftentimes the difference between how we as faculty answer that question and how students answer that question is really important, right? As Madison and I were talking about, you know, what brings you to study engineering provides that motivation for why you're going to do this program of study. But as faculty, we're thinking about, well, this is the specific class that I have to teach, and these are the learning objectives that are important for that class. And we completely miss why the student is even in that major in the first place. And by missing that, we miss the opportunity to really help that student develop an understanding of why this specific thing is important to what it was that brought them into the discipline in the first place.
Yeah. John?
So one of my colleagues in graduate school, Phil Brown, if you remember him, Rashida, studied engineers' career goals. And I remember specifically one of the example cases he would use was a student who came into mechanical engineering wanting to design bikes. That's it. He just wanted to graduate and become a bike designer and own a bike shop. And so I always think, like, if I were to talk to that mechanical engineering student in terms of cars or planes, he doesn't care. He just wants to design bikes. And so, like, by not bringing in that student's interest, that might make him think, well, is this the program I should be in if I want to be a person who owns a bike shop and design bikes? So I agree with Fred, it's important.
I think it does depend on the class. And this is speaking as somebody who's not an engineer. I'm very conscious of legally I cannot claim to be one. I never took an engineering course. I am an applied physicist, so I get around that saying, okay, I'm an applied physicist, not an engineer. But when I'm teaching like thermo and statistics, courses that's almost every student takes, so I have this broad spectrum of students in there. I'm really trying to emphasize what are the skills that all engineers need to have. What is the problem solving? How do you approach these problems and so forth? Versus if I was teaching a very specific course, like on vibration, that would be a very specific course, and my goal and the way I approach that would be very, very different. So, you know, I'm trying to think, what are the kind of the things that all engineers need to know? And in some ways, I look at thermodynamics. Yeah, I'm teaching material, but more importantly, I'm teaching you how to think and how to analyze these problems and how to approach them, not as much as the students may think I'm really trying to teach them thermo. I'm teaching them engineering. So I think it does depend on the course.
Okay.
And I'm also thinking on the same line with Dr. Baez and John, that, and you actually, that you can, it's really hard if you have 100 students or even 50 students in your class to have this conversation as to, what is your interest? Is your interest bikes or is your interest planes? With students from so many areas as well in my section. So we discover all of this by having conversations during office hours where I had students that said, I am in here because my mom and dad pushed me to because I have the skills, I don't like what I'm doing, or this is what I'm good at and I'm starting to like it or hate it. And it's my job to see in that field what would be, for my class, what would be something that would be interested for them in that field, biological or like mechanical or whatever, civil engineers.
Okay. All right. So thank you all for your responses. And I think this is a great segue into my next slide of thinking about that the type of engineer that you might become or describe yourself also has some relation to what type of courses you're talking about and what type of courses you're taking. So in thinking about, you have engineering over here and you may have engineering specific courses. You may also have courses of philosophy and business administration and writing or whatever else over here. And at some point, you know, they overlap. And I want you to think about what type of courses actually made you feel like the engineer that you are today. Let's take a couple minutes, think about it, discuss with the neighbor, and then we'll report out.
Yeah, that's
So do I have any volunteers? Which course or courses made you feel like the engineer you are today? Yes.
Last semester I took the Energy 1, the first part of thermodynamics and heat transfer, and then also statics and an intro to environmental engineering. And I think the common theme between all of those was finally feeling like all the math and all the physics that's kind of just over by itself, where you're just sort of learning equations, how to solve problems, and maybe what some of these units mean. But in Intro to Environmental Engineering, it was very much like, here's your problem, here's this population of this city, figure out how much coal you might need to run its power plant. That was finally like, oh, I can use math, I can use physics to like do something with it and find a useful answer. So those were my classes.
Okay. I see your hand.
Yeah, for me it was the machine design and manufacturing classes because I took mechanical engineering and wasn't introduced to machine design until I think the end of third year back home. I got my undergrad from India. Yeah, when the machines actually started coming in, the manufacturing part, that's when I felt, okay, now this is why I chose mechanical. So I think, yeah, it really depends on some really like thermodynamics. I love the manufacturing and design ones.
So we talked about one of the biggest factors in it, and I think that the biggest factor is the kind of professor that teaches the course, because sometimes we have courses where the professor may not communicate, I guess, as well, or we don't resonate well with each other, so that kind of gets in the way of learning the material at that type of level. So the courses that I've enjoyed the most were the ones where the professor was teaching it in the best ways for me.
I don't know that I've ever had a particular class that made me feel like an engineer. For me, it's more project based. Like when I was building rigs, the house sensing equipment down in the ocean that can withstand bottom forces, that made me feel like an engineer. Or like even when I'm at home and I just built some shelves, like figuring out how much weight a joist can hold, that made me feel like an engineer. But I think the classes just taught me how to do that, I guess.
Okay. Yeah.
Yeah, just follow up. I think the practical experience, like the course will offer, like a practical experience, like a capstone project, something like that. So can you have a feeling like how you apply the theoretical knowledge onto your real project? Working together as a group, get some real hands-on experience. That makes me feel like an engineer rather than just a pure scientist.
Okay. For Ari and I, we're on the same page of our dissertations.
All right, thank you for your responses. Let me know if I'm in the same ballpark here, but just to summarize what I've heard a little bit of motivation. So the things that align most with what you're motivated to do and why you got into engineering are the ones that made you feel like an engineer. So those courses align with your motivation, help with that. I also heard the practical applications of it. So maybe not one particular course, but a combination of courses that has enabled you to do an engineering related task that has made you feel like an engineer. Does that sound about right? Okay, excellent. So those things are important when we think about this overlap and what kind of engineer we define ourselves as, and thinking about, well, if this is how we define engineering for ourselves, how do we think our students define engineering, and how can we help them define engineering for them? Okay. So in thinking about this overlap, my work is mainly in first year engineering courses, but really exploring how different students of sophomore, juniors, seniors describe, answer the exact question that I asked you of, what makes you feel like an engineer? And so students who took a general first year engineering course where you cover a lot of different topics, there's nothing too specific to any particular major, they said that they were engineers, or they were becoming engineers. They knew how to problem solve, they knew how to work with teams, they knew how to communicate, they understood ethical considerations of engineering, and all those things are great. Does anyone have anything to add of what an engineer should be able to do of those lists? All right, so it seems like people are on a similar page here. What's interesting is that students who take a first year engineering course that is specific to their major, when they're asked what type of engineer they are, they say, I am X engineer. So in the purpose for my dissertation, I was interviewing students who were in electrical and computer engineering. And so by being able to be successful in their first year engineering course, which was specific to learning circuits and an overview of digital logic design and all of the things that as electrical and computer engineers we consider the basics, by being able to be successful in that course to build a circuit in their lab classes, they felt, I am becoming an electrical, or I am becoming a computer engineer. And it was very interesting how distinct those types of students were able to say, this is the engineer I'm becoming, as opposed to students who were in a broader coursework and they talk about some of the bigger roles of team building and communication and all of those things that we try to build in or integrate into discipline-specific courses, but may not always translate when you ask students what they're doing and what they're learning. So I bring this back to thinking about, does it matter how students define what type of engineer they are or becoming? And we don't have to answer this again because we talked about it, but I want to leave you with this thought of knowing that depending on what course you may be teaching may actually impact what type of engineer your student thinks they are. If you're teaching a philosophy course, they may not feel that they're an engineer because they got an A in philosophy, as opposed to if they got an A in thermo, they might feel like they're becoming a mechanical engineer. Or for me, it was microfabrication courses. When I got A in that class, I was like, yes, I'm doing what it means to be an electrical engineer for me. The guy who wanted to learn how to build bikes, when he took a class that was probably related to helping him building bikes, that probably was his thing of, I'm becoming a mechanical engineer. So I want you to think about those things in terms of the courses that you're taking for graduate students, the courses that you're teaching as faculty members or future faculty members, and how that impacts students and their development of self-efficacy in becoming an engineer. And so in thinking about what kind of engineers we are preparing, common ways of how we see self-efficacy develop is mastery experiences. We know homeworks and labs and exams, those things that are really repetitive. We see that talked about a lot with students. Social persuasions in terms of peer reviews and feedback, being able to hear back from people who they respect, even timely feedback from their professors. That helps reassure or reaffirm what they're doing, if they're on the right track in their courses. And then vicarious experiences for majority students. And when I say majority students, these are the students who can see themselves in engineering. And that's typically people who are not underrepresented. Uncommon ways of developing self-efficacy is the vicarious piece for underrepresented students. We're talking about women, we're talking about people who may be from low socioeconomic status, people from diverse backgrounds. They don't see a lot of engineers who look like them, and so those vicarious experiences are more uncommon for them because there's not a lot of people that they can emulate to say, oh, if they can do it, I can do it too. And then somatic and emotional state, measuring feelings. You know, how do you measure feelings? It's such a, it's an underexplored realm, but it's a really fascinating realm. And the young lady spoke about it in the back, where if the professor can be engaging, if you can connect with your students in the classroom, then it may not even matter what they're teaching, but they're captivated by who you are as an instructor. That's the piece that makes them feel, you know, I like this, or I'm able to learn from this. And that gets captured in those feelings, but has been underexplored in the research realm, and I think that it's going to be really important to see how that develops. And so in thinking about ways to move forward, especially for the spaces that are underdeveloped, so for vicarious experiences, taking a little bit of extra step of being able to provide examples for those who are not traditionally in engineering, and those are people who may not be one of the following. So also thinking about differently abled people in engineering. You know, one of the things that I noticed in Driftmeyer is that we now have Braille on our signage, on our doors. And I thought that's a great inclusive way to make sure that people know what they're doing. Like, as engineers, you should be able to create an accessible environment for everyone that you may encounter. And then, again, for somatic and emotional state, understanding how can we measure feelings and where can we go with that and what are some things that we can do. And I know that there's some work in terms of empathy and engineering that is being explored. There's definitely a lot more room for exploration in this, and to see how that impacts the way that we research engineering and how people develop engineering identity and belonging in engineering, as well as, you know, how do we incorporate that research into our classrooms so that students are developing the type of engineer that they would like to be. So, again, doesn't matter of how we're developing engineers and thinking about what course that you're teaching, right? And the ways that you can incorporate the type of engineer that they're becoming. And maybe it's important to do both. You know, it's important for our students to know ethics, to know communication, to know teamwork. It's also important for them to know circuits and electromagnetic fields and signals and systems. That's an electrical engineering thing. Those are the ones I can think of. So it's important for our students to be able to do both, all right? The question is, how can we incorporate the things that we're learning from research and from practice so that we're able to help our students not choose between the type of engineer that they're becoming, but they're becoming a well-rounded one.
Thank you everyone so much for coming. Thank you to Rashida. And I hope to see you all next month.